In this lesson, we are going to find theoretical and experimental probabilities, and we're going to find geometric probabilities. The probability of an event is the number between 0 and 1 that indicates the likelihood that the event will occur. Here are some sample probabilities and their meanings. If the probability of an event is 0, that means the event will not occur. If it is 0.25, the probability that it's 25%. If it is 0.5, it's equally likely to occur or not occur. 0.75 will occur, and then if it's 1 or 100%, it's most certain to occur. So the theoretical probability is the probability that of an event where it's the number of outcomes that we want divided by the total number of outcomes. So in other words, on the top is the information we want, and in the bottom is the total amount. For example, if I want to calculate the probability of drawing a king out of a deck of cards, I would put the amount of kings in the top, which is 4, divided by the total number of cards, which would be 52. Let's take a look at the difference between experimental probability and geometric probability. Experimental probability is the probability determined by performing an experiment, conducting a survey, or maybe looking at the history of an event. For geometric probability, we're taking the probability found by calculating the ratio of two lengths, or of area, or of volume, and then dividing by the total area. Let's take a look at some examples. A spinner has 8 equal size sectors numbered from 1 to 8. Find the probability of spinning a 6. Well, on the 8 equal sized sectors numbered from 1 to 8, there is one section that's numbered 6 out of 8. So the probability of spinning a 6 would be 1 out of 8. This can also be written as a decimal, which is 0.125, or then converted to a percent, which would be 12.5%. The second question, part B, spinning a number greater than 5. So I want the probability of spinning greater than 5. Spinning greater than 5 means I'm not counting the number 5, but I would count the number 6, 7, and 8. So there would be 3 choices out of a total of 8. And again, we can write this as a decimal, 0.375, or we can write it as a percent, 37.5%. 5 cards are drawn from a standard 52-card deck. What is the probability that the first 2 cards are red? There's a couple of ways that we can work this out. So finding the probability that the cards are red, and I want to find the probability that the first 2 that I draw. Well, we can do this in a couple of ways. The first way is that the first card that I draw that is red would mean that there are 26 red cards out of 52. And when I make my second choice, I would have already taken 1 card out of the deck. So there would be 25 red cards left, and there would be only 51 cards left in the deck. So when I multiply these together, I can actually simplify 26 out of 52, simplify that to 1/2, and multiply that by 25 out of 51. And that gives me 25 over 102, which I can convert to a decimal, which would be 0.245 approximately, or 24.5%. The second way that we can do this problem is to use combinations to calculate. And taking a look back at the definition of probability is that it is the number of outcomes in the event that I'm talking about divided by the total amount of outcomes. So what I'm talking about in this example is red cards. So I would like to take the combination. There are 26 red cards, and I'm going to pick 2 of them, divided by the total. And the total would be that there are 52 cards in a deck, and I'm going to worry about picking 2 of them. So I can use my calculator to do those if I would like. It does come out to be 25 over 102. exact same thing that I get here, which is 0.245 or 24.5%. Let's take a look at the next example. There are 9 students on the math team. You draw their names one by one to determine the order in which they answer questions at a math meet. What is the probability that 3 out of the 5 seniors on the team will be chosen last in any order? So here's what we are talking about. Any order means it can be a combination. So what I'm going to take is what I want first, and I want 3 out of the 5 to be seniors. So my combination means I have 5 seniors and I'm picking 3 of them. Out of the total amount, there are 9 students on the math team and I am picking 3 of them. That gives me 11.9%. I can also do it by picking by multiplying with the probabilities. So I could have 5 seniors out of 9, and once I pick one, I would have 4 seniors left out of 8 total math students on the team, times I would have 3 seniors left to pick one from out of 7 students, and that also gives me 11.9%. So I can work it out either way. Next question. You made 15 of 21 free throw attempts. Find the probability that you will make the next free throw. So I have made 15 out of 21. That's going to give me 0.714 or 71.4%. Also, if we wanted to leave that in fraction form, we could reduce that to 5/7. In the next question, the bar graph shown gives the resident population in thousands of the United States in 1997. For a randomly selected person in the United States, find the probability of the given event. So in 1997, I want to find out that the person is 24 years old or under. So I take a look at the 24 or under, which is 94,507, and I need to divide that by the total population of people that were surveyed. So I need to add together all of the people that were surveyed to come up with my denominator, or the bottom of my probability, which is 267,637. So my probability would be about 0.353, which is about 35.3%. The person is at least 45 years old. So at least means they could be 45 or older. So then in this case, I need to add these two together, which is going to be 89,522, and again divided by the total that were surveyed, which is 267,637. And remember, these are also in thousands. So we would add our extra zeros on. But that comes out to be about 0.334, which is about 33.4%. Next, we are working with geometric probability, and it says find the probability that a randomly thrown dart will hit the shaded portion of the target shown below. So the first thing that we want to talk about is that we want to find the entire area of our rectangle. And because we have 2 circles right here, we're going to assume that the height is the diameter of the circle. And so that would be 4 units. And so since that's the diameter of the circle, we can then say that this is 8 units long. So the area of our rectangle would be 32 units. Now, what we want to do is we want the area that is shaded only. So we want to take the area of the entire figure and we want to subtract the circles. Remember that the area of the circle is pi r squared, and so I want 2 of those circles. The radius will be half of the diameter, which is 2, and 2 squared is 4. So that will be pi r squared will be 4 pi. So I want to take 32 minus 8 pi divided by 32. And that calculates to be 0.215 or approximately 21.5%. Is the probability that I would land a dart in the shaded region. In our next example, a store is open from 8 a.m. to 8 p.m. The manager works from 9 a.m. to 4 p.m. What is the probability that the manager is there during the same time as a customer who arrives randomly during the store's hours of operation and stays for 15 minutes? So I think it's easiest if we make a diagram of our store hours. So our store opens at 8 a.m. and closes at 8 p.m. The manager is there from 9 a.m. until 4 p.m. So what we want to know is how many time periods that the manager is there. So from 9 a.m. to 4 p.m. is 7 hours. Every 15 minutes means that there are 4 slots every hour. So that gives us 28. However, we do need to subtract one of those 15 of those intervals because we want to make sure that they are on the 27th interval, which would be at 3:45, that they are there for that 15 minutes. So that gives us 27 different slots that a customer could come in for 15 minutes while the manager is in the store. Now we're going to take a look at how long the store is open. It's open from 8 a.m. to 8 p.m., which is 12 hours, and each hour has 4 slots, that's 15 minutes, though that gives us 48 different times that are 15 minutes, but we do want to subtract one from that because we want to make sure we realize that if it's for a 15-minute interval, the last one begins at 7:45. So we're going to take 27 divided by 47, and the probability that the customer will come in and stay for 15 minutes while the manager is in the store is 0.574, which is approximately 57.4%. So to review, we need to know the difference between experimental and theoretical probability, the method of calculating probability, and the methods of calculating geometric probability.